In section 5.2, we're going to start trying to figure out some error range. And so to do that, the first thing we're going to have to do is figure out a critical value. But I want to talk a little bit about the error range. We're estimating an interval that's going to capture from our point estimate the true proportion of the population in this case. And so we know that we have normal data, maybe, sorry here, grab my pen after a little wavy action. And so our premise here is that we've got this p hat in the middle from our sample, and that's our point estimate. And then we're figuring out, again, that idea of a net that's going to capture it. And we have some kind of confidence. Now, a pretty typical one is 95% confident. And so if we cast our net, we're saying that this here, the area in the middle, is 95%. And all of these, we're pretty confident we're going to catch all those true proportions that are in there. And we have a limit on this side, which is p hat plus our error range, our margin of error. And then on the other side, we have p hat minus our error range. Now in the next session, we're going to talk about finding the error range. In this session, we're really going to figure out the critical value piece to it. And so the critical value, with our confidence interval, we have some error range that we're allowing here. And our confidence level plus our error range alpha is going to be equal to that whole area under the curve. So in this picture here, we have some error here and some error here in the tails. Now we're interested in figuring out what that area is. So if we work here and say we have a 95% confidence, I'll say 0.95 plus my alpha, that error in the tails, is equal to 1. And so we'll subtract this here and maybe get an alpha equal to 0.05. Now that's the error in both tails. So the whole combined alpha is right here and here. But you'll hear me talk quite a bit about tail area, and this tail area is divided in 2. And so that's our alpha over 2, and if we divide this by 2, we get 0.025 for how much area is in each tail. 0.025 here and 0.025 here. Now we talked a little bit in hypothesis testing about tails, and so this is a two-tailed scenario. Now we are going to use Excel or another tool to figure out a z-score corresponding to that area. And so it's still, we've got our normal curve here. Okay, that was pretty bad. Our normal curve here, and say 0 is in the middle. We're looking for some scores on each end, and these are going to be the z, maybe, alpha over 2, and then z alpha over 2 that are going to give us these little spots here. Kind of missed the window a little bit. But this is relating back to something that we have done, and we know the area in these tails is 0.025. So to find that critical value, okay, ignore the spelling there. Sometimes it takes a little while for it to show up here. Anyway, so our critical value, we're going to be able to do norm, standard, inverse. And I'm going to just take the small side, the left-hand side, and 0.025 here. And we can throw that into Excel. And when we do that, this gives us a value of 1.96 for that critical value. And actually, because it's on the left-hand side, it gives us a value of negative 1.96. But we're just going to concern ourselves with the positive version. Oops, I got rid of the 1 there. 1.96. Because of symmetry, over here, this is negative 1.96, and this over here is 1.96. Now I could do normal standard inverse of 0.95 plus 0.025 and get that right hand side value, but it's not necessarily that useful that I do that. So I'm going to swing down here to an example. We're going to try to find a critical value if we have a confidence level of 88% here, sorry. So again, to draw the picture, somewhere in the middle, and I'm just trying to make this is 0.88, which means my tail area is 1 minus 0.88, so that's 0.12, and that's actually alpha. And then a single tail, an alpha over 2, is 0.06. And then if I want to find a z-score, so that tells me here that this area is 0.06 and this area 0.06. And again, we're kind of lazy as mathematicians, so we'll say z alpha over 2 is the norm S inverse of 0.06, and that gives us a value of 1.555, and again it's negative. I rounded that to 3 decimal places, so then our critical value, z alpha over 2, and we just take the positive version of that. So I could say maybe 1.56 if I stop there, but I'm going to go to 3 in this case. Now the text has some confidence levels and their corresponding critical values. These are ones that get used a lot, and so I'll write these down. I don't always remember these. I use the system in Excel to find the ones I don't know. So for a 90% confidence level, splitting into 2 tails, we get a critical value of 1.645. For a 95% confidence level, we get 1.96, which was here earlier. And then 99% is another one that we like, and that is 2.576. And so these critical values are going to be a piece of what we're doing in the next video as we continue moving on to more and more accuracy here. But this is just part of it, and it also relates back to some stuff that we've done previously. So stay tuned for that.